Yeah, so my presentation is about investigating the correlation between rainfall and other weather patterns and the performance of 5G networks and high frequency networks. So the motivation behind this project is that 5G networks use what are typically millimeter wavelengths, so very high frequency waves, and these are especially susceptible to signal attenuation from rainfall and other weather patterns. So you can see here that as the frequency of the wave increases, that the attenuation effects also increase dramatically. So this wasn't as big of a problem for like 3G or 4G like previous generations, but it is for this. And beyond understanding the correlation between rainfall and signal attenuation, we want to try to predict future attenuation of links so that we can potentially redirect traffic. So that's the downstream application. Okay, so the roadmap for this project is we're going to collect network data, specifically from NYCMesh, which is a community-built wireless network offering internet to New Yorkers. The second step would be collecting weather data and precipitation data. And for this, I use Weather Underground, which is a commercial weather service. And then we're going to correlate the data in the third step. Okay, so New York City Mesh, like I said, is a city-scale wireless network. And many of the links in this network are high frequency and thus susceptible to this link degradation that I talked about from rain-induced. So here we can see basically all of the links in New York City Mesh. And these blue links are like backhaul links. So that's where the majority of traffic flows through. And those are the links that I examined in my analysis. And then this is a sample link, and then this is a weather station. So the idea here is if we get a weather station that is close to the link and we see, let's say, a period of precipitation recorded by the weather station, then we would expect the performance of the link to be affected. Yeah, so some helpful information. So a wireless link can be thought of as a pipe through which data is transmitted. So here we have two radio towers, right? And they can either transmit or receive information. And we're going to use link data, especially signal attenuation, data rate, link capacity, different measurements to evaluate the link performance. Okay, so the data collection basically went as follows. So first, we wanted to filter out the links by frequency. So that because only the higher frequency links are the backhaul links where the majority of data is transmitted. So you can see here a great majority of the links are not backhaul links, but these links here, these links here are the ones we want to analyze. Yeah, and then here we see basically this is the API for NYCMesh. So these are the statistics for like a radio device. And so, yeah, so specifically the ones that I wanted to analyze are signal 60G, and uplink capacity, because these are the ones in the literature that are most directly affected by rain and other weather patterns. Yeah, so anyway, so I wrote a script to collect the data by looping through and making repeated calls to the API. And then I did a consistency check of the time between successive measurements. And we were able to find that basically data is collected every minute for the past week. And then it's downsampled over time. So like a month ago, it might be collected every hour. So I guess the top line there is that it was important to collect data as soon as possible after it was released. Okay, so yeah, then the next step was collecting the precipitation data. So we used Weather Underground to do this. And we basically needed two requirements for the precipitation data. One, we wanted very hyperlocal measurements. So we wanted hundreds of weather stations throughout New York City. And the second is we wanted measurements with high frequency. So ideally like 5-minute time intervals, so that we could precisely see the effect that it had on the weather-induced link attenuation. Yeah, so here is on their website, like a table of the measurements. And so we used various tools and stuff to like a beautiful soup library to get it into a pandas data frame. Okay, yeah, there's a video animation here. I guess it's not showing, but basically, yeah, you iterate over each of the latitude longitude coordinates. Unfortunately, Weather Underground doesn't allow you to get all the personal weather stations directly. So you have to use what's called the near API to basically get nearby weather stations. Okay. Yeah, and then so now we have all of the relevant data. So now what we're going to try to do is find the correlation between the data. So specifically for each weather station, we want to compute what's called a Pearson correlation coefficient between the weather station time series rainfall and the signal values for basically the link to get a correlation. And this is the formula that we would use. And the other downstream task is to get all weather stations which are close to the link. And in order to do that efficiently, we figured out that we could take advantage of the KD tree data structure. And this could be used to find near neighbors efficiently, basically. So yeah, that's what I've been working on over the summer. And yeah, any questions?
Great.
Yeah, thank you.